Continuing with that. So limits of acceptability imposed on the length of a certain batch of the metal rolls are in between that range. Okay, too long, too short doesn't work. It is observed that on average 5% are rejected as undersized and 10% are rejected as oversized. Assuming the net lengths are normally distributed, find the mean and standard deviation of this distribution. Alright, this is the trickiest question you will have for normal. Okay, that's the trickiest question you will have for normal. Because mean and standard deviation doesn't give it. And the two areas are not the same. Okay, look at those two areas. I'll just ask you one thing. Let's plot this on the. Let's plot this first. Why I just give so little space? Well, that's fine. 5% is undersized. That's 1.925. That must be 5%. And 10% stayed as oversized. That's 2075. That must be 10%. Okay. Me and mu doesn't give it. Okay, I don't know that. Okay, another thing making this question even harder is the two areas are not the same. The two areas are not the same. The original question was, this oversize is 5% as well. Okay, oversize is 5% as well. Why is make it easier if that's 5% and 5%? Why is easier if I say 5% and 5%? Symmetrical, and then I can find the mu directly. Okay, I can find the mu directly. Add them, divide by 2, I will directly have the mu if the area is just symmetrical. But it's not symmetrical. Okay, it's not symmetrical, so it's not given directly. So I need to work out both mu and standard deviation, and that's the hard part. Okay, if two areas are the same on each side, then it's easy to do. Okay, symmetrical. So it's not symmetrical here, very unlucky. That's a 10%. Okay, what method I'll use is the Z standardized to Z. Standardized to Z. So what I will do here is not enough space. I'll just use here. Okay, I'll have a Z curve. All right. I'll plot 5% here, and I'll plot 10% here. Okay. And plot back to the Z normal. Plot back to the Z normal. You will have 1.925 minus mu divided by standard deviation, and 2.075 minus mu divided by standard deviation. Okay, that's how you plot them back into the Z normal. Okay, minus mu, well, let's just say x. That length is x. Length is x. X is normally distributed by mu and standard deviation, all unknown. Alright, so what I will do is now go to, I don't have space, I've just showed this on the calculator and you can understand it, I hope. Menu 3.1, and I want 2 things, and then that's 1.0. Menu 3.1 and 2. Just wait, my calculator stuck. Menu 3.1, and then that I want solving 2 equations. Okay, the first one is a division 1.0, not 0, 1.925 9 to 5. Okay, minus x divided by y. Okay, mu and standard deviation. What that will equals to? That will equals to mu 5, 5, 3 inverse. I have the area 0.05, mu 0 and standard deviation 1. Those two values must be equivalent. I can't do that. I need to find that out first. Sorry. Mu 5, 5, 3 and 0.05, 0 and 1. That's the value, okay? You have that. And you have another one is 5, 5, 3. You want 0.95. Not 95, 90. 0.9. Okay, because it's 10% on the other side. You only look for the left. It's 90%, which is 0.9. And 0 and 1 as well. So you have this value here. And then you go for menu 3, 1 to solve. Okay, you're solving them simultaneously. 1.295 minus x divided by y. Go this way, equals to this value here. Okay, and the other one is 2.075 minus x divided by y. And that equals to this one. Okay, this one. Control Z. Yes, worked. Which value I'm looking for? This value. Okay, and bring this down here. Comma x, comma y. Make sure you leave enough decimals. Okay, make sure you leave enough decimals. Alright. Magic part. Okay, we have it. Mu is 1.733. Yes. Yes. Is that? It's not. Okay. 925. It's okay. Easily changed. 925. 925. Okay. Okay. Oh yes. That make better sense. Okay. 2.009 and 0.05 is the standard deviation. Okay, so solve them simultaneously. If that's 2.2 area and it's not symmetrical area, so you need to use this way to do it. Okay, back to standardized normal, and then finding the values. So, just give 3 decimal places as well. Mu is 2.009, and standard deviation is 0.051. 0.051. Yep. Okay, that's the mu and standard deviation. That's how we use the Z plot. Okay, Z back. Go to the Z standardized, and then think about the area. Because on the standardized curve, I know exactly which point give you below 5%, above 10%. Okay? Questions? This is the hardest type you can have. Okay? So there's no way you use cats. You must do by hand, and then you must go back to the standardized set normal curve. Okay. Next question. Next question says, Jack randomly select 8 metal rows from this particular batch and give your answer correctly 4 decimal places. What is the probability that the first 2 and the last 2 she selected were rejected ones? Okay, what's the probability you will get rejected? What's the probability of rejection? When you will get rejected? It's very easy question. It's given in the original paragraph already. Under what condition this thing will be rejected? Okay, acceptability is like when you accept it. Okay, when you get rejected. Don't tell me you don't know this. If you don't know this, I can't continue. And is under or after is all get rejected. Okay, it says here. Can you see? Is are rejected as undersized and 10% are rejected as oversized. So what's the probability get rejected? 15%, yes. Okay, it can't get too long or too short. It must be in between that range. Okay, so 15% is the reject rate. Okay, so you want the first two and the last two will reject once. Okay, so you want like 8 in total. So not, yes, not. That's what you want. Okay, so is that 8? Yes, it's 8. So first two and last two. So what's the reject rate for the first one is 8.5, and the next one is 8.5 at 0.15 squared, and acceptable one is 0.85, and you repeat 4 times, and then 0.15 squared. Okay, just times all the probability together. First one 0.15, second one 1.5, 0.85, 85, 85, 85, 0.15, 0.15, and times them together. Okay, next question are the hard ones. Okay, what is the probability she will select at least 4 acceptable in the size of the metal rolls? Okay, so let Y be the number of metal rolls accepted. Okay, so the acceptable ones are X, Y. Okay, so Y must be a binomial distribution with 8. She selects 8 in total, and the acceptable rate is 0.85. That is a binomial distribution. Okay, so 8. Every single one have the same rejection rate and the acceptable rate. So that is a binomial distribution. So what I want is probability Y that at least Y greater or equals to 4. Okay, so 4, 5, 6, 7, 8. And that's a binomial distribution. Menu 55E, because CDF, I have 8. I have 0.85. I have lower bound is 4. Upper bound is 8. Okay, at least 4. 0.9971. Okay, 0.9971. Okay, it must be you need to understand, yes, the length of the rows is normally distributed, but the number of rows, metal rows get selected will be binomial distribution. Okay, it's 2 distribution mixed up together here. You can have more kinds of distribution mixed up in the VCAL question, so that will be quite similar to the type. Okay, it's quite similar to this type. Yeah. Menu 55E. Binomial CDF, because it's like a range of values 4, 5, 6, 7, 8, not only like 4. Questions? No? Okay, last one. What is the probability that the length of the 3 metals she selects are between 1.95 and 2.05? Okay, those 2 values are not given in the question. So what you want to find is the probability that the X, the length of the metal rows are in between that. Okay, so you need to find that probability for a single one first. Every single one will get the same probability of in between those 2 values. So that's a calculator question as well. So you go menu 552. Okay, so the lower bound is 1.95, and that's 2.05. So mean is, I totally forgot the mean. The mean is what I find. 2.009. Well, it's not exact. I should leave more decimals, but it's okay. I don't want to go back to have a look again. You should leave more decimals or save that as A. Better show you that. Okay, let's just cancel this. Okay, what you have for your mean is this number, right? Let's copy this number down and go Control VAR, give a letter A to that and enter that. Your A means that already, so you don't need to write that down. And then you go, this number is the standard deviation. Let's go Control VAR of B. Okay, B is given as well. So I go menu 552. Go, I forgot again, my God. 1.95. Too many numbers. I should have a note next time besides me. 2.05. Mu is A. Okay, given A, and that gives B. The standard deviation is B. Press OK. Okay, that directly shows you the probability. Okay, 0.6627, like something like that. 0.66272737. Okay, just keep going like that. And then the length of between, I want exactly 3. Okay, exactly 3. So I want that is as 3/8, and then is this probability of 3 and 1 minus this probability of 5. Okay, it's a binomial case again. 8, I want exactly 3 worked. Okay, so is that 2 power 3 and 1 minus that. Or you can just use your calculator to do that. Okay, a calculator question. I save the p-value. That's the p-value. Okay, Control VAR P. Let's just save that as P. That's the successful read. Menu 55D is the number of trials I have should be 8. I want the successful read is P. And I want that x to be 3 exactly. Okay, and directly have that 0.0711. Okay, 0.0711. Okay, any questions? This question is very, very important and very hard. Okay, the whole thing is a mix-up. It's exactly the exam type of question. Okay, it's a mix of finding mean, standard deviation, mixed with binomial distribution and normal distribution. So everything you need to know in that question. Okay, and the way how you define the letter to represent the number is important as well. You can't like copy. You don't want to type again and again and again of one number. So just save that number as a letter, and then every time you type the letter, it will come up. But you need to remember what letter you actually saved. Okay. Wait, I will save that one.